Okay, I wanted to talk a little bit about environments. This is where we keep our variable declarations, right? So if you think about Scala, we have this difference between the val and the var. The val is immutable, and the var can change, right? Um, and environments are a place where we keep our vals, essentially. The variables, they typically are references or pointers to locations in memory, and we'll deal with that when we come to memory management. But the vals themselves, right, they are just these bindings between strings and values. And that's what we keep an environment for. The environment's not technically part of your programming language, but it's a part of the interpreter, right? The interpreter needs to keep track of all of the variables that you have defined, and it keeps that in the environment. Now, a simple way to handle environments is like a Scala map function, right? So it's a dictionary, if you will, in Python, and all it does is it takes strings and maps them to values, right? So maybe x is 1.2, y is true, and z is 300. And if we wanted to look up an element in the map, we can just look up the string value and return whatever or the string key and return whatever its value happens to be. Now, for this course, we're going to have to modify the environment later when we talk about recursion. So I think it's useful to just build up our own domain-specific language for environments. Right, so what does that mean? It means that we're going to come up with our abstract syntax for it, and then some semantic rules that will let environments work on their own, and then our interpreter will be able to just use these rules naturally, just like it uses the rules for lettuce. So how are we going to do that? Well, we're going to let's define the grammar first. So an environment is going to be, right, it can be either an empty environment, or it could be an extension. We'll call it extend, and we'll have a string and a value, and then an old environment. Right, so the idea here is that anytime, like I have a let statement, let x equal 10 in x plus 15, right, this x plus 10, when we actually do this definition, we'll add a new extend on here with x as s and 10 as v, and then whatever the old environment, right, there's probably some let statements up here, and this is a small fragment of my code. And so we'll already have an environment maybe defined up above. If there was nothing, it'll be an empty environment. And we'll just extend it with our new definition of x and 10, right? So you can sort of, let's take this map and convert it into this language, right? So this would look like extend x 1.2, extend y true, extend z 300, and what should this last one be? It should be the empty environment. Right, so we see that this is just a nested sequence of environments. And you should also maybe notice that this looks just like the cons construction that we had before, but instead of a single element added onto the front of the list, onto the head of the list, we have two different things added onto the head of the list every single time. And then we have essentially the tail of the list, right? Why would we want to do this? Well, it's useful because it allows us to do scoping pretty effortlessly, right? So we have our abstract syntax here. And what else do we need? Well, we need the semantics. So what do we want to be able to do with this? Well, we want to be able to look up an element in this in an environment and then return the value that it's bound to, right? So I want to be able to look up x and figure out that, oh, x is actually 1.2. So we need a function called lookup. and it should look up some identifier s, right, a string, in some local environment, and it should return something. Well, what are some options? Right, so one case is, well, what happens if env is the empty environment? Right, well, there's obviously s does not exist in the empty environment, nothing exists in the empty environment. So we want to return an error, right? We just try to like look up a variable that doesn't exist. For instance, if we had y plus x plus y over here and we're looking up y, we would eventually get to an empty environment where this would turn up as an error. So this is rule number one, right? So maybe we'll call it lookup error. It's always useful to name the rules, right? So that way we can know which ones we're applying. Okay, so what happens if we don't have an error? So we'll want to look up s in the environment. And right, there's one, and what's going to happen here? My pen is dying. Well, what can I do? How do I normally sort of approach going through a cons list like this, right? Through a linked list. Well, I look at my head of my list and I say, hey, is s equal to the head of this list, right? And if it is, then I just want to return the value there. If it isn't, then I want to recurse on the rest of the list here. Right, so we're going to have two different rules, right? So we look up s and env, and we say, well, if env has the form, right, it's an extends, and we have, let's call it t and v and old environment, right, and t is equal to s, then we want to return v. Right, so maybe this is found, lookup found. And lastly, if we try to look up s in an environment, and let's say, again, env has this form, extend t, v, and old environment. And well, what's the other option? T is not equal to s, right? Well, then this should be lookup s in the old environment. All right, so we just have a little recursion going on right there. If that's readable. So we have s, old environment, and lookup. We'll call it lookup recurse. So yeah, this is t not equal to s. Great, and this makes a lot of sense. We're just going to sort of walk through our list. So for instance, if we wanted to look up, let's say y, what happens? Well, we will this will be our original environment, and so we'll try to look up y, and we'll see that, we'll look right here, right, and we'll see, oh, that's not y. Okay, so let's recurse onto this unit. Now we'll do the same thing here. Oh, is this y? It is. Okay, so let's return true. And that's all there really is to the lookup process. We're going to keep on walking through. Let's try to look up a variable that doesn't exist here. Let's do, say, like lookup a in our environment. Well, what happens? We compare a to this string. That's not a. Okay, so then we recurse down to here. Look up a in this string. Oh, that doesn't exist. Okay, let's recurse down here. Is this equal to a? No, it isn't. Let's recurse to here. Oh, our environment is the empty environment. So we're going to return an error, and that's going to percolate its way back up. Right, this will end up being an error, and the previous version will be an error all the way back up. What about if we have something like, right, we we're talking about shadowing. So we had something like x and 10 in x equals 20 in x plus 30, right? What should this evaluate to? Well, this x shadows this x. So the x that's actually looked up here should be this definition of x and not this one. And we'll see when we come to the actual abstract grammar for the let statement how this works. But what does the environment end up looking like for this, right? It's going to look like this. Extend x 20, extend x 10, and empty environment. Couple parentheses. And the idea here is that when I get down to this location, I'm going to have to look up x in my environment. And what I do is I look at the very first element and I say, oh, there it is. Cool, I'll return 20. And this has naturally just shadowed this definition of x, because as we look through our environment, we'll look at the first element first and then the next one, right? And we'll take the very first definition that we see of that value. So there could be a couple of different definitions of x deep in this environment, but once we get into this scope, we will only see that top level one, right? Because we exit out of our lookup as soon as we see the first indication of an x and return whatever that first value of it is. So this little construction of an environment naturally handles shadowing for us. And we'll be using this throughout the course, right? Again, you can think of it as a simple map, right? That's all it's really doing, but it's doing it in this sort of linked list format. And the fact that we keep a smaller copy of our old environment lets us both look up through our old environment, but also lets us shadow very naturally.